presenting. And thanks, Catherine. You can get us started.
Great. Yeah. So as Alexa said, this was our project to look at different stabilization methods. It was a collaboration between Saltwater, Regeneration North, and the CERC. So the primary objectives were to test different stabilization methods and identify energy, labor, and cost-efficient methods to stabilize kelp. We focused on four. The first was a modified high tunnel. The second was testing some alternative dryers. The third was fermentation. And then we tested salting. So the modified high tunnel, we had had a commercial high tunnel in operation in 2022 and 2023 with limited or weather-dependent success, I would say. We got some input from the UAA Department of Engineering and made some modifications. We resized some vents. We added a mechanical vent tied to a temperature and humidity controller. We installed a commercial dehumidifier and an air-to-air heat pump. We monitored using a sensor push and a smart outlet meter. And we also added lines above our prior hanging lines to increase the capacity. So the outcomes were that we had faster drying times, which was great. Still took about 24 hours average. There were some days that it was even longer, but we also were able to increase the volume by about 20% by just adding those higher lines to the high tunnel. And the end product was a high quality whole leaf milled whole leaf and milled food product that we were able to sell all of. And actually we had more demand than supply. The next thing we tried was in our sort of effort to find a more efficient way to dry kelp, we tested an IR dryer. We had planned to test it in Alaska, but it hadn't been moved up to Alaska until fairly recently. So we shipped 180 pounds of frozen kelp to Washington State. And Evie participated in about 2.5 days of testing via video conference. I would say based on that limited test, it's fairly energy intensive, had fairly low volume output. The content of moisture was below the target, and further testing is warranted. It is now on the Kenai, and there are plans to process some more kelp through it, hopefully this season. When that IR dryer was unavailable, we decided we would look outside to see if there were some other possible dryers in the US that we could test. We identified this company, Beltomatic, through just sort of online research and exchanges with them. They were very confident they could dry kelp. We sent down, it's a mid-size conveyor food dryer based in Indiana. So we shipped 10 pounds of frozen kelp down to their headquarters. They ran it through and said, ooh, yuck. No, this is way too labor intensive and we're not really that interested in this. And that was kind of the end of that test. But it was a learning experience, and now everybody else knows that Veltomatic is probably not the place to go. So the next thing we tested was fermentation. Fermentation is known to be a reliable primary processing method for both food grade and soil amendment products. We made 6 test batches. This was definitely Evie's domain, so she can help answer any questions about this, using sugar and molasses and with and without lactobacillus bacteria. We monitored it for 20 to 30 days, filtered out the liquids, and sent them for lab analysis. We also conducted a community workshop in collaboration with CERC out at the Native Village at Port Graham, and also had participants come to our hub in Homer. The outcomes of this were that fermentation was much less labor intensive, or I would say more labor and energy efficient than any of the drying approaches we had been testing. It did produce viable bioactive product. We did not pursue food, but it could be used as a food product. But that was not something we really pursued at all. We did feel that it was viable for some community processing activities, given the low energy and input requirements. and that there is potential to scale given growing markets, both national or US and global. So we will be testing that further this season. The next thing and the last approach we tested was salting. Salting is a traditional way of preserving food. We tested two methods. Basically, both involve salting layered kelp heavily with coarse, or salting layered kelp heavily with coarse salt in well-ventilated totes that could drain naturally. We sent samples to the Midwest labs for nutrition, composition, and food safety testing, and to the Kodiak Marine Science Center for mold testing. We didn't sell anybody, but we shared it with chefs and friends in exchange for their feedback. What we found was that the water activity level was reached in approximately 6 days, 6 to 7 days. It was relatively energy and labor efficient. It produced a shelf-stable food product. We vacuum packed 1 pound packages and we provided them to this local chef in Homer, who put it in his miso soup recipe and was awarded first place in the annual culinary event Taste of Homer. So it is palatable and adaptable, but the market is nascent and we're not exactly sure yet what the demand might be, but we're going to be testing that some more this season. So just in summary, we felt that the diversified approaches expanded both our capacity and markets. Almost all the methods tested were energy efficient and varied in labor intensity. The exception to that was the IR dryer. Scaling, fermentation, and salting are the focus of our current work. We're also going to be continuing to focus on building community capacity. And one of the challenges will be continuing to match markets to each product stream and developing those different market and distribution channels as we develop different products. So that's all I have.
Thank you so much, Catherine. And I will open up for Q&A. Anyone is welcome to turn on their microphone and video, or if you want to pop questions into the chat, I'm happy to ask them for you. Okay, we have a question coming in. For fermentation, did you use a commercial fermentation starter? And did you add anything besides kelp?
Yeah, hi, Thu. For some of the batches, I added a commercial lactobacillus strain, and some I did not. For all of the batches, I used some amount of a feeder of sugar or molasses and varied that amount. Happy to share those results if you're interested.
I have a question for you. Do you think that you'll be able to meet the demand for the products this year? And is that the plan to keep scaling up?
We are certainly trying, but we are having quite a growth in demand. So we're sorting out whether both the production levels of the farms and the capacity to dry will meet our demand.
Yeah, and I would say that's largely a function of the high tunnel as a dryer is it's a really great tool at the small scale, but it doesn't match. It's not that our demand is so huge, it's that the dryer itself is limited our capacity. We need a different drying system.
Yeah.
Mm-hmm. Are you thinking about some drying system that has that is constant flow kind of throughput dryer to kind of to meet that potential accelerated or larger volume?
I'd say ideally, but we haven't found. We're also trying to balance it with energy use, right? And I don't feel like we have found. We're working on that research, but I'm not sure that we found the right machine to match the energy cost at our base in Homer. And I don't know, Catherine, do you have anything to add to that?
No, just that we will be testing a batch dryer this season. The Salmon Sisters, which is the facility we use as the Salmon Sisters the former fish plant in Homer. That's where all of these activities have taken place. And they purchased a batch dryer. So we're going to be testing that. We're not sure how much that will increase our capacity, but we're hoping that it will maybe double what we're able to produce. And yeah, we'll be looking at other options. We're not expecting it to solve the problem.
Yeah, and I would say if anyone out there has ideas, we'd love to have a conversation about. I feel like the Holy Grail is a relatively small scale continuous feed belt dryer that is, that is not that's relatively energy efficient, and that could be replicated as the markets grow. But I don't feel like we found that yet.
No, that's kind of what we hoped the Beltomatic might be, but it wasn't. Or at least they weren't willing to kind of mess around with it long enough to find out.
Is that batch dryer? Is that the harvest saver, or is it?
It's an Enviro pack.
Okay. Yeah, because I've tried it. I did the harvest saver, which is actually a pretty reasonable unit. They're about 20 something grand, and but they're gas powered, which is a challenge for most places where we don't have gas. So, um, it's really not easy. Did you find the heat pump to be effective?
Yes. The heat pump was a great tool. It was really a great addition to the high tunnel. And especially on days when the weather outside was not conducive to drying, it's what made the difference. And we didn't have to use it when it was, sunny and breezy outside. We found we didn't need to use it. But it was a great tool. But we also feel like we've really maxed out the efficiency of the high tunnel. We've put, as Catherine said, it still took sometimes over 24 hours to dry, but we also, by adding more lines, we were drying more kelp way more efficiently with all the additions this past in the 2024 season. But I don't think any of us see where we can squeeze more efficiency out of that tool.
Well, thank you so much for sharing. It was a great presentation and excited to see how things evolve and move forward. I will go ahead and introduce the next presenters. This is Otherlab and Premium Aquatics. I'm not sure if Marcos or John is going to be speaking today, but they will be talking about their project on helical anchor performance analysis.
Well, John's the star. I'm just carrying bags, so you can talk.
All right, thanks, Marcos. I'll start talking. So our project was to evaluate the efficacy of helical anchors in mariculture, and particularly related to Marcos's kelp farm up there. So we are Otherlab / Anchorbot, a company that makes a machine that installs helical anchors underwater remotely. So that's the perspective we're coming from this, coming at for this. Let me see if I can.
It's very cool.
I'll show a picture in a minute. My first slides are boring. So the thesis here is that anchoring is too expensive, and it's really cutting down the ability of people to get farms in the water and get larger areas under cultivation to help scale the industry. So we're aiming to come in and get anchors in at, say, less than $2,500 a piece, including, say, $1,000 worth of the anchor equipment itself, and then not that much addition to get the labor and the equipment mobilized up to do the work. We are targeting the ability to put the stuff in with smaller vessels. So rather than having to hire somebody with either a real lot of bollard pull on their vessel or barges and cranes to put in heavier anchors, we want to do this with smaller anchors with workboats that are already existing on site. And what we're trying to give you is accurate anchor placement in deep water so that the anchoring costs can get down to a reasonable level. And in looking at that, we would need to figure out where are the cases that this is actually beneficial. So this happens to work. It doesn't really work for 1 to 5 anchors, but it works great at the 30 to 100 anchor scale because it just costs some amount to get everybody mobilized and get this equipment up there and working. And we're also looking at replacing bigger anchors. So in places where you have, say, a 30,000-pound concrete block is your answer, we could put in a 50-pound helical instead and get you the same strength. And one of the benefits that I wanted to talk about and point out is that when you use helical anchors, they can take a lot of vertical load on the lines, whereas traditional drag anchors and block anchors don't as much. So you can reduce the scope that your anchor lines are taking up in your lease. So I just did a quick diagram that shows a 100-acre plot in 100 feet of water. And if you were to use helicals, you can get to 88 acres under cultivation. Versus if you had, say, a 4-to-1 line scope on a drag anchor, then you're only farming 57 acres of that. So if that's part of your economics, it makes sense to try to push for these anchors rather than the way it's been done until now. So looking at what we've done in this project, we basically got out, wanted to characterize the site, see what we could learn about the sediment. So we took some cores and we're making sure that we had a variety of different sites to look at. And then we came back a year later and put in a bunch of anchors and pulled them out to see how strong they were. Feel free to jump in anytime, Marcos, if you want to tell me things.
Yeah, well, I think one of my interests in this was exactly what you talk about, just lowering the mooring cost and expanding the amount of farmable space in a site lease is, both economically provides a pretty remarkable opportunity. So I was interested to see how effective it was, and I think I was really happy with what happened.
All right, so I'm just going to go through a little bit of what this looks like in the picture slides here. So we took, Marcos was able to procure a gravity core, which is a tube that has a big weight that follows it down, and you just free fall this off the side of your boat. And we were able to sample a bunch of different sites, and we got all kinds of different good stuff. We had shells, mud, rock, clay, sand, and bedrock. So we had a variety of things we could work in. Here's some pictures of what we got. Some of this is this really elastic clay. You can see on the top right, we had a bunch of shell layers in there. Some of these even came up with wood chips. So we had a variety of stuff. And in the center bottom, we smashed the core directly into bedrock. So we had everything. We had everything from zero to perfectly smooth sand in all these different samples. Here's pictures of where we worked. We were down in southeast. The sort of top right yellow dot is Craig, and down a little south and east of that is Marcos's current farm, and then the other sites are potential places where we're looking at working. This is what we bring. Small kit of gear. We can show up in a van if we have to. So we're not, we don't have a big footprint when we get to someone's dock or on someone's boat. For anyone who has not used helical anchors yet, this is what they look like. They are just a circular disc and a steel shaft that comes up to the surface, and we embed these by screwing them in like a normal screw. And here's a picture of the machine we brought up there. It is neutrally buoyant when it carries an anchor, so you can drive it around with the game controller, and you have video feedback, so you can see what you're doing if the water is clear. If you don't, you also have acoustic navigation to get it to a target location. It's on a tether that you spool out, and it carries the anchor down, and then it's kind of an inverted helicopter. So when you spin it around, the blades create a bunch of downforce that push the anchor in, and it carries your mooring lines with it. So after you release the anchor, you bring back the mooring line to the surface. And at that point, you can just clip a buoy on it and drive away. And also, I guess, yeah, we're speccing this to 100 meters depth. And during this trip, we worked down to about 200 feet, so 70 meters-ish.
Yeah, about that.
Yeah. Here's a quick picture of a launch and recovery. It's really nice to have overhead lifting capability. We've done this from small davits. This boat was great. It happened to have a nice overhead crane, so we had no problems. But the whole thing with an anchor on it weighs about 200 pounds. So you can roll it into the water. But go ahead, Marcus.
We used a seiner and ran it off the picking boom on the seiner, and it worked great.
Yeah, that was pretty ideal operations. Then we used their winch to pull out the anchors with a load cell and measured how much force it took to get our anchors ripped out. And we got some data back from these. Along the bottom axis is the pullout strength in kilos. So 1,000 kilos is a ton, 2,000 kilos is 2 tons. And the vertical axis is the amount of torque it took to install it, which is sort of our internal metric of how strong the anchor should be. This is considered a known relationship. More torque equals more pullout strength, but it varies with the type of sediment you get. And we are currently working with a group down at Port Hueneme at the Navy in California, where they've got some physicists who are really into figuring this out. So we hope to have kind of a better grip on what we measure to how hard the anchor is going to hold later on. But for the moment, what we do is put in one anchor and pull it out and say, we kind of understand that this much torque will put in an anchor that pulls out at this much strength. So we had a bunch of successful anchors, and we were pulling out at several tons of force in this site. Just to finish up quickly, I think we learned sediment depth is important, and at a bunch of the sites around that area, there is not as much sediment near the shore, and as you head out offshore, you get a lot more sediment. So there may be cases where we want to do a project that uses one kind of anchor inshore because there's not much sediment, and then these helicals in the offshore range where we're good at putting in stuff at deeper depths. We think we can install up to 5 tons anchors in that area with the machine we've currently got. We also learned that shipping logistics really can dominate the overall project time. So it may make sense to situate some equipment up there to kind of stay local if we can come up with enough business up there so that we don't have to ship things back and forth, because that was a big deal. And yeah, we need to improve some of our deck gear, and we're really confident going down to at least 200 feet now, throwing in some anchors. So I'll stop there and see what people have for questions.
Exciting. Do we have any questions from the group? Again, feel free to occupy the chat and I can ask for you.
Well, one of the things that that we found is when we were putting in moorings for the oyster and the seaweed farm, we had to use some pretty substantial assets, and this in many of those applications could have been a suitable substitute. So I mean, if you can do you can do a few big anchors, you could do a series of smaller anchors, which provides redundancy, lower cost, and you get that, you get a real good. The bottom type is pretty important. Rock didn't work well, but which is a lot of what Southeast is. But in the bays where we were, you do your bottom survey through the gravity core, and you can ascertain how much substrate do you have to work with, and in some places you have to use gravity or a Danforth or something else. But in a lot of these places, you found there were areas where we did one core sample where it was 8 feet deep of mud, and so the broad range of different things that you could do. So when you did your mooring plan, you could say, all right, for these 12 anchors on this side, we could do helicals, and then over here along the shoreline where it's steep and rocky, we have to use something else because it doesn't have the right substrate. But a mixture of the two would be a more efficient and cost-effective mooring system than what's been adapted so far.
I had a question about the cost efficiency. John, you said it starts to make economic sense at 30 to 100 anchors. Is that what you said? And do you see ways to make it do you see a path forward for making it make economic sense for smaller farms or at a smaller number?
Yeah, that's really just related to the mobilization cost. So if we have people traveling and we're shipping gear up there and the gear's out of service for a week of transport before and a week of transport after, then the cost per anchor doesn't come down until you do that. So if we get a partner up there who owns a machine or is running a machine regularly, then that cost can come way down, and it would just make sense to say, drive around the bay for a day and install anchors, then you can do 3, 5, whatever it be.
So, I mean, you could coordinate multiple farms, could say, hey, we're gonna do this all we're gonna do in the month of June or something like that, and you do your own mobilization and you do a bunch of anchors around a region at the same time. I think that's where the cost effectiveness really starts to be demonstrated.
Yeah, that makes sense. Thank you. Helpful.
Sure.
I have one question in the chat here. How long did you leave the anchor before pulling it?
We pulled those out right away. So we would install an anchor and would never let go of the line. So we would take it off the machine, pull the installer on board, and then
we still have one in. I think we still have one in that's been there all winter, and we'll pull it out sometime this summer.
Yeah.
All
And we didn't do the sort of most scientific pull out. If you wanted, the scientists like you to test these by pulling them to a certain strength and then waiting 5 minutes and then pulling them up to another strength and waiting 5 minutes and then pulling it. And we just went for kind of a peak load as sort of an opportunistic manner.
I will say that 5,000 is it could be quite a bit more. We had one where we're doing the load, and the line that connected the load cell on it failed when we were at about 4,500 pounds, but it would have gone much higher. And then we had to tow on it with the seiner to get it to pull out, and it was it really took some effort to get that out of the bottom. But you could see it on you could see the pull on the flukes on the anchor. Kind of took them like this, made it like this. So a lot of force to pull that out.
All right. It looks like we have another question in the chat, but I'm going to keep moving just for time's sake to make sure we have appropriate timing for everyone. So, John, if you could answer in the chat, that would be great. And I will have Max come up here. We have Barnacle Foods presenting on their project of evaluating and sharing methods to efficiently dry kelp for rural communities.
Thanks, Alex, and everybody. Don't have any slides, so just going to do a real quick chat of what we did for our research and how that kind of wrapped up. Like Alex said, looking at drying methods. I think a lot of people around the state are looking at this as well. And we were thinking specifically kind of what would be like a smaller scale and what equipment might work. The thought being people coming into the industry that don't really have any knowledge, either from various communities or people looking to start farming, just to have somewhere that they can go as a first step and get familiarized with different equipment, different processes, different techniques for drying. So our first one that we report that we put out for the grant project was just a high-level overview of all different types of drying technologies and what's currently being used where. For the second one, we then looked and tested a few of them and then gave some thoughts and some recommendations. One of the things that we looked at was mechanical dewatering, as we've heard that this has been done. Some people have done this, some people haven't, specifically with screw presses or plate and frame presses. The thought being that thermal drying has high energy costs, and so if you could reduce the water by essentially pressing out the moisture from the kelp at the beginning, that you would then reduce the amount that it needs to have the thermal input and reduce overall costs. What we found is that, yes, you do get water reduction from that, but it's probably not worth it in our estimation to use this in a drying line. These are pretty expensive pieces of equipment, and you don't get a tremendous amount of water reduction, and then it's pretty low throughput unless you really scale up on the size. So it's something that we don't think will continue to look at for our own use. Probably wouldn't recommend for most small scale drying operations either. There's also some concern that what you are pressing might be squeezing out a lot of the nutrients or a lot of the composition that you actually want at the end, depending what your end use is. So from there, then we hopped on to some testing of thermal drying equipment. We did both a rotary dryer and a cabinet dryer, and then looked at the conveyor dryer that's on the East Coast. With the rotary dryer, we did that just kind of more conceptually. Would this work? Yes, it works. That's what we've been drying for a long time. Ours specifically is inefficient. But we think, yeah, as a concept, this will work, and we're excited to see the Syracuse dryer that's getting installed up in Prince William Sound to see how that goes, because it's a yeah, same concept, but just built specifically for kelp drying. And then with the cabinet dehydrator, that's what we use to take a few more measurements to get kind of an energy usage understanding for drying. And the kind of the biggest takeaway, one of the big takeaways that we found from that is that knowing the end product is going to be kind of key for, I mean, all processing, but drying also specifically. Depending the water activity level. Water activity level is the measurement that you use to determine whether or not food or kelp is shelf stable and will inhibit microbial growth. And so there's kind of a standard level that needs to be below to be considered food safe. But then as you continue to go down, or there can be impacts on texture, on flavor, etc. So knowing what the end use is important for that, because you can dry down to a very low level, really dry it out if you say you want a really crispy product, but that will take a lot more time and a lot more energy. Whereas if you just need to stabilize it and then it's going to be processed in a different manner, you could dry it not to that degree and save a lot on time and energy cost. And so that was kind of the big takeaway from us. With the dryer that we used was, or the hydrator we used was just a little benchtop size dryer, just to get kind of some energy measurements on that, some timing measurements on that. But it seems that relationship will of course continue as it scales up, and even yeah, as it continue to scale up. Yeah, so I think that's kind of the biggest takeaways that we found. Of course, in a lot of the small communities, energy costs can be quite high. So looking at any sort of system that uses a heat pump, you're going to be restricted to electricity in almost all communities. So a heat pump system is going to help reduce energy costs. And then there's also the balance between energy costs, capital equipment costs, and labor. So kind of just triangulating between those three to see what would work best, given the location and given the size of the producer or the farm. So yeah, that's kind of a summation of our report. And I see Evie just said in the chat, did we did you use a screw press for dewatering and or test other tools? Yeah, Evie, we only used a screw press for dewatering, and we didn't test it ourselves. We sent it away to two different screw press manufacturers, and they did the testing in-house. We also looked at plate and frame presses, but we didn't figure that was going to be best suited.
Quick question, Max. Does this dry a lot faster if you kind of open the skin, like if you somewhat cut the leaves rather than, like I'm thinking like not a full like maceration or something, but just to get a somewhat smaller pieces? Is there anything?
Yeah, I think it definitely would help. And that's what Oceans Balance is doing on the East Coast with their conveyor dryers. They do have a size reduction step just to increase that surface area. Also, what can help is freezing, and so freezing, you then have the cell burst, and you get a lot of liquid that comes out from that. So that kind of steps you up and does a similar um, process to a screw press or to a mechanical dewatering step. So yeah, I think a size reduction. Also with the size reduction step, then you have less tendency for clumping of the material. It's easier to spread out in a uniform layer, so it will dry consistently.
Thanks.
Great. Well, thanks everybody. Yeah, looking forward to hearing more about the other presentations.
Yeah, thank you so much, Max. And again, if anyone has follow-up questions, just enter them into the chat and we can keep moving along here. So up next we have Greenwave. I think Sam is here presenting on the project Kelp Stabilization for Rural Communities, Designing for Decentralized Processing. Hi, Sam.
Hi, give me a second here. All right, can you guys see that?
Yes.
Awesome. Okay, cool. So our project was a collaboration between Greenwave and these four entities here. The kelp was grown by Alaska Ocean Farms. We, as you'll see, partnered heavily with Alaska Sea Grant and did a lot of our processing in their facility in Kodiak. And then we also worked closely with Callie to make sure that all of our work was kind of grounded in what would work for rural communities. And then Macro Oceans was a core partner in providing the stabilization method and actually buying some kelp that came out of it. So this project was really focused on, sorry.
I don't see your screen anymore. Does anyone else still see the screen? Maybe it's.
I can see the screen.
Oh, you can. Okay, then there's
Yep,
something
I can
on
see
here.
it.
Sorry for interrupting. I'll figure it out.
Okay. No worries. No worries. So as the name of our project suggests, we were really focused on this stabilization piece of the value chain, which is super, super critical, particularly for areas that are further away from centralized processing and transportation and that sort of thing. So the aim here was really to figure out, well, how could we use wet ambient temperature stabilization methods in a really low cost, low footprint, low energy way to make it possible for some of these rural communities to access kelp markets. So Macro Ocean's process is what we would consider an ambient temperature stabilization technique. We've heard already today about fermentation as an option. This is a method that uses chemical reagents to stabilize certain components of the kelp. Very much depends on what you're looking for in your end product, obviously. So Macro Oceans is looking for very specific things to be preserved and other things they don't care about at all. So for example, if you were interested in protein, this method would not work for you. This method isn't that they use is all about preserving the sugars and the polysaccharides. But at its core, there's a lot of different wet ambient temperature stabilization methods, and they all sort of require the same basic steps, which are first, size reduction, very important to get a coating of the chemical reagents onto the kelp. And then, some sort of dosing and mixing. And we like this because even though it doesn't take out the water, which is obviously you've just heard about a few ways that people have tried to do that, the ability to store your kelp anywhere in any temperature and not have to pay for additional, cold storage is pretty great. So our project was to, first of all, select some equipment that would efficiently reduce the whole kelp into a slurry. We didn't want there to be any pre-processing steps that needed to happen, just wanted to go from raw kelp into chopped kelp very, very quickly. We then wanted to mix that with Macro Oceans reagents, ship it to California. And then there's a big component of this project, which was actually demoing this line for folks from rural communities, getting their feedback and iterating on that. And then, of course, making everything available, telling everyone what we did. So the size reduction equipment was really a big piece of this, figuring out what exactly that piece of technology was. I'm not going to read off all these requirements, but these were our requirements for the size reduction technology. And some of the more important ones were the food safe option. We didn't want to do something that worked for non-food uses and not for food uses. And no water for conveyance is another big one when it comes to ambient temperature stabilization, because some of those recipes have very specific ratios, and you can't be required to put water through it, because that would mess that up. We tried a lot of stuff. Here's a list of some stuff that we tried. We tried garbage disposals, meat grinders, wood chippers. We tried the Urshel. We tried a dual shaft shredder. And there were a lot of, with each of these, there were pros and cons. Again, we were really looking for something that was low energy, low footprint, and cheap, and that you could get pretty much anywhere, that was easy. Because we didn't want to, sorry, a piece of that is the repair and the maintenance. We wanted that to be minimal, and you should be able to do that using anything you could get at a normal hardware store. So the Vincent VS8 shredder is what we arrived at. This has several larger models, which we'll talk about in a bit. But we decided on this machine because it is specifically designed for bulky wet materials. There's no real blades. It just kind of smashes the kelp instead of cutting it. And the company provides this ability to try before you buy. So you could rent it, which is what we did for this project. And you can really, really do a lot with it. And they don't care the condition it comes back in. So that's pretty great. Again, we were aiming for a really cheap, small line. So the other equipment that we used here, not fancy. we had a stand for the shredder. We transferred kelp between the shredder and the storage vessel with just some buckets, and we used a right angle drill and paddle mixer to mix it up with the reagents. And we did all this at the KSMSC pilot plant in Kodiak. This was an amazing space, an amazing facility to bring equipment into, to be able to use the equipment that they had there, the sinks, the floor drains, everything. So really would highly recommend partnering with KSMSC for those of you who want to do these projects again in the future. It was a really great experience for us. And so, yeah, we had this demo day where we brought in folks from all over Alaska, as well as even further afield, to actually get hands-on with this equipment and tell us what worked and what they thought needed some improvement. These are some specific questions we asked them about how they might adapt it to work in their context. And we did end up making quite a few changes as a result of that demo day. We really improved the conveyance. So getting the kelp out of the shredder, they didn't want to be schlepping buckets around. That's totally fair. So we borrowed an auger from Blue Evolution, which is something that we would recommend. And conveyance kind of rose to the top of our awareness as something that really needs to be looked at if you're going to minimize labor in processing. And so that both goes for the kelp coming into the machine and also the kelp coming out of the machine. And even though there were some inefficiencies there, as you can see down here at the bottom, we were able to increase our throughput just by making very small improvements. So we went from about 1,000 pounds an hour to 2,000 pounds an hour. Again, this is just the chopping stuff, but still, it was pretty good for a small machine and for only a $20,000 investment. Oops. So what happened to the kelp? We shipped it to macro oceans. It's been stored at ambient temperature. Some of it is still being stored at ambient temperature. They've been analyzing it monthly to validate that it works. And the good news is that it does work. However, we also learned that the mixing technique is really, really important. So our low tech, cheap and cheerful method maybe was not the best option. And so that just is a lesson learned, and things we need to do better going forward and as we continue to increase volumes. This was a continuation. This project was a continuation of a pilot that Greenwave did with macro oceans at our New Haven, Connecticut facility in the previous year in 2022-23. And so we've been gradually increasing volumes. And as many of you on this call know, with each increase in volume, the more you realize, how the details matter and how you really need to dial in what those procedures are for your new volumes. So the mixing was not an issue when we did 1,000 pounds in New Haven. It was an issue when we did 5,000 pounds in Kodiak. So some quick takeaways. We were really happy with our choice of shredder, and there are bigger options. So the number that 8 refers to the diameter of the shaft. So there's an 8-inch opening, 12-inch opening, or an 18-inch opening. We're getting several 12-inch opening ones for this year's projects. The stabilization technique did work to preserve polysaccharides in both sugar kelp and bull kelp, and we were really excited with the throughput. Our lessons learned were we were originally supposed to get some kelp from some of the native villages who are participating in kelp farming for the first time. And unfortunately, we were unable to do that because they could not get their permits in time. So permitting still a bottleneck there. We, again, the in-feed and conveyance, really big when it comes to moving larger volumes and keeping that labor cost down. And then that mixing step is pretty important. But in terms of like big picture outcomes, I also want to highlight that in addition to the Joint Innovation Project, this line was actually used by 2 commercial buyers in Kodiak last year. So we kept the equipment there for a couple extra weeks, and it was used to process 30,000 pounds of kelp, which really just helped to further de-risk this equipment and help us, everyone involved, see what needed to be invested in this year. And this year we applied for the Ag Product Development Grant, and a larger version of this line is being commissioned in Kodiak, and it's going to be used to process about 250,000 pounds for 4 different commercial buyers. So in terms of like a JIP success story, I would say that this, it's been a really nice transition to just be able to like bit by bit build up. And I think everybody's feeling pretty confident about what we have planned this year because of what we were able to do last year. So that's what I got.
Thank you so much, Sam. It's really
Yeah.
exciting to hear how everything's moved along and how it's growing in operation this year as well. Do we have any questions from the group here?
I got one.
Go ahead, John.
What is the upper temperature limit on ambient temperature storage? Does that run out at some point?
Good question. I mean, it totally depends on the process. Like for macro oceans, my understanding is that they keep it in an unrefrigerated warehouse in Sacramento, so quite hot. And it does, every method's different though. So for some of the biostimulant folks who are going to be using essentially the same processing line, that the numbers are different for each of their processes because they're mixing different reagents in with it.
Thanks.
Yeah.
Is all of the kelp this year being is that all going towards the biostimulant project, or it's going in various directions?
No. So we've got about 180,000 pounds going to 2 different biostimulant customers, and then I think around 50 going to macro oceans, and then there's a smaller amount that's going to another. I actually don't know if it's biostimulant, another non-food use. Yeah.
All right. Yeah,
I
go
see
ahead.
Juanetta and
Juanetta, do
Marcos.
you want to
Yeah.
go ahead?
Thank you. Sam, do you have a sort of a down the line estimate about in terms of scalability? Where do you need to get in terms of throughput for a sustainable business model? And does that include capital replacement costs?
Yeah, good question. The throughput requirements are, I mean, we are trying to step it up bit by bit. Everyone wants, to maximize all the things, but our goal for this year is 20,000 pounds a day. How that translates to a profitable business model is sort of still TBD, because we don't know what all the costs are associated with the 20,000 pounds a day yet. And it also does depend on the what the end product is. So that's been one of the interesting things about using the same equipment line for multiple products, is that some of the customers want to be able to do 100,000 pounds a day because that's what works for their business model, and others of them say, well, if we could do 5,000 pounds a day, that would be fine, that would work for us. So it's when I'm thinking of it as in terms of like a blended model. So like if you have a line that's being used for several different products, like what is the volume that's going through for each product, and kind of titrating that with how much money people stand to make off of it for that particular product line.
Mhm. Thank you.
Yeah.
Go ahead, Marcos.
Yeah, so I envision a line for this is you've got a hopper on one end that feeds into the chopper through a conveyor. That chopper feeds into another conveyor that goes into something where it mixes a slurry with an auto injection system at the right rate, and then
Mhm.
and then there's a mixing motion to get coverage throughout it, all mechanical, and then it comes
Mhm.
go into whatever your holding thing is. Did in this trial, did you use an auto injection structure, or did you just pour your
Yeah.
volume in and do a batch? And
Yeah, we just poured it in. We just dosed it at the end. And the reason for that is because we were really focused on this rural component. Like it was sort of both and, because we are setting up we have our eye on setting up a central processing line in Kodiak that can handle the 250,000 pound volume this year. And we were thinking, okay, but for folks on the other side of Kodiak, for the folks on the far side of the island, like, could they next year do the macro oceans process or the Pacific Northwest organics process, like do it themselves over there, and because it's ambient temperature, just like wait until the next larger vessel that makes sense for them to transport it to town. So we don't think it's reasonable to expect that all of them will be able to get the fully automated line. So that's kind of why we kept that out of it. But yeah, for the central processing line, I would say absolutely as much automation as possible would be great.
yeah, and then you can duplicate them or make them bigger if you want to increase volume, and you can I can see the model in my head. I haven't tried it, but I haven't. But it seems like it would make sense.
Yeah, for sure.
And train. So you would put these in IBCs or barrels or what?
IBC, yeah. Well, so for the rural context, barrels make a lot more sense just because you don't need a
Easier to
forklift to
move.
move them around. You can, with two people, you can just move them around. But in a centralized context, yeah, IBCs.
Would you contemplate moving this product in the fermented state somewhere, or doing the secondary processing, the biostimulant manufacturing at the same location?
That's really up to the customer. I mean, so far, what I've seen is that the customers who we're working with are thinking that because there is IP involved in the final product, they're not really too keen on doing the final value added product in Alaska, because that would require them giving up their recipe to people they don't know very far away. So in each of these cases, what they're creating with this stabilization is a temporary like kelp ingredient that then they're taking to their central place and mixing with a bunch of other stuff to make their final product. And that gives them some sense of security that they're someone could steal their kelp concentrate recipe, but they're not going to steal their entire end product.
What we might look at is we have all these big tenders that you could put that slurry in a tender and do one run a year since it's stable, and just run make that run. It's weather permitting, it's 3 or 4 days to say California, 5 days maybe, but even so you could make do 200 tons, 300 tons of product, run it down, deliver it, and then make the run back. It might be a less
Yeah.
expensive way to do it than trying to put IBCs and fill them in 40-foot containers and put them on a barge and transport them to Seattle and then put them on a truck and transport them to California, as a
Yeah.
way of really reducing that cost. I know we looked at it, and it actually, I think it makes sense.
Yeah. I agree.
Right, Evie?
Evie?
Yeah, Sam, I was just wondering if you could expand a little bit on ideas for conveyance. If you don't have an auger that you can borrow, and I know
Fair.
has experimented with like a log conveyor belt, and just wondering if you have any kind of pearls of wisdom on other ways to try to.
Yeah, we are actively experimenting with that in New Haven right now. Basically, just buying a bunch of stuff on eBay. I mean, the same thing we did with the the same thing we did with the shredder, right? Like everyone thinks their machine's going to work, and then they send it to you, and you're like, oh, nope, doesn't work. So, yeah, we've tried the fire. We actually have a firewood conveyor already in New Haven, and it worked pretty well for the whole kelp. That worked fine. We have an auger that is similar to the Blue Evolution one that's coming to New Haven, and we're going to try that out too. But the like everybody thinks you can pump it. It's actually not as easy to pump it as you would think. So, and again, there's like the water issue. It pumps if there's a lot of liquid in it already, but how do you get it to move if you can't flood it with liquid and it's not like in solution, essentially, is a big question. So hopefully we'll have more for you on that this year.
Great, thank you.
Mm-hmm.
Thank you so much for sharing, Sam.
Yeah, you're welcome.
All right, we can move ahead to Atlantic Sea Farms. A few here presenting on building a product bridge, cost-effective primary stabilization for transportation of Alaska kelp to market. Sue, are you here with us?
Sorry, got to take
Please.
myself off. There we are. Yeah. Am I sharing my screen right now?
Not yet.
Why
Unless
is this
my
not
computer, unless something's up with on my end again.
How about now? Share, allow, open, allow. There we go. Oh, for God's sakes. Sorry about this.
No worries.
It's making me quit and reopen to share. Well, in the meantime, while Zoom tells me I can't do what I'm trying to do.
You can send it over to me via email quickly if you need to as well.
Yeah, let me just do that real quickly because it's asking for permission on here and well, all right. Now can you see me?
Yes.
Okay, perfect. So thank you, Sam, for essentially talking already about most of the things that I am going to be covering here. Our approach here was just to look specifically at the liquid preservation and ways that we could do that. And again, I'm not going to go into this in super detail, but you can be called chemical stabilization or pickling, even cooking, but it's not all this fancy of a technique. If you've put pickles into a jar and made that, you're familiar with the basic process. For our project, we were really looking at having 3 goals. We wanted our method to be able to be stored at room temperature. We're trying to get away from cold storage, or at least have another option other than freezing and transporting through cold storage. And we set a rather modest goal of having it be shelf stable for more than 3 months and tracing that with minimal microbial activity, as well as sensory panel analysis. And we wanted it to cost less than freezing or drying that we have currently. This was just one of the reports that was done by the Alaskan Food Kelp, but basically that some of the key things are limited drying infrastructure and difficulty shipping kelp to the lower 48. Now, talking a bit about our process, on the top, it really does not require a whole bunch of equipment, with the exception of the ability to shred and move the shreds into containers, as Sam already talked about. But you are working with some food grade acids, so gloves, apron, and some definitely safety goggles, as Bill Nye would say, wear your safety goggles. Equipment is, in terms of the hardware, pH meter is probably the most elaborate piece of lab equipment, then a source for water, some mixing containers, a scale, and then, as we found, a blender being really, really helpful. Wish we had thought of this beforehand. And then your inputs, which are very inexpensive. It's just food grade acids, salts, and then if you decide you want a little extra insurance, some microbial inhibitors like sodium benzoate or potassium sorbate, although we found that we didn't always need those. The real capital expenses comes to the containers that you're putting in them. So we've tried both ICB totes as well as food grade 55-gallon barrels, like Sam was talking about, as well as 5-gallon buckets for our sort of mesocosm experiments. And then a place that you can do all of this with some food safety concerns in mind and store them. Sorry. And does it work? Yes. So this is actually ones that we just got back. This is one of our brine test results, and we had this across 6 of our different brines. So they had been in this for a total of 12 months. No yeast or mold detected, no E. coli, salmonella, bacteria, listeria, all of the microbial nasties you might be worried about. And these were done in those 55-gallon barrels on pallets, which we could easily move around just like that. And just thought people here might be most interested. What we've come up with, we've actually come up with several different ways. This is probably the lowest cost that got best results for us, but it's just a mixture. We do a 1-to-1 ratio of liquid to kelp. And what that comes out to is, 1,000 liters of water, 20 kilos of salts. You can go higher depending on what your final desired product is, but I really don't recommend leaving the salt out because you have real texture issues. And then we found that no one acid gives you great texture results, but by combining different ones. So in this case, we've had really good luck using a mixture of citric acid and food grade phosphoric acid. And then some potassium sorbate, which is, in our tests, has been the best at keeping yeasts down. But again, if you're not as concerned about it being a food grade product, or if you're shipping into markets that don't want potassium sorbate, which is generally regarded as safe, but some vendors don't allow or want you to use it, we've had similar microbial scores leaving it out entirely. Second one, just to kind of show you what we've used in our formulas, it's exactly the same formula, except we substituted out the phosphoric acid for lactic acid. This one had a much closer sensory panel to lacto-fermented, which is what all of our existing products rely on, and is another very common preservation method that Evie was talking about earlier on today. So flavor sensory profile wants to more closely match that. That's another direction to go. We also experimented using various amounts of acetic acid, which just gives you the sort of vinegar taste and profile of, vinegar fermentation. And the only downside with that is it is by far the most expensive of food grade acids to use, but worked just as well. It was one of those rare experiments where almost all the different brine components that we tried worked in the end. Oh, sorry. So why am I missing one slide? Oh, yeah. So in terms of the actual methods to doing this, the way that we had this set up is to mix and weigh the brine or the fermentation stabilization liquid, just measuring each of the individual components and then checking your pH. We were going for a brine pH between 2.6 and 2.8 to start out. And then the tricky part comes in with the kelp itself, which being a living organism and the growing environment having a lot to do with it, you have to do some fine tuning. And we finally realized that a much better way of doing this is to, because when you mix the brine with the kelp is more alkaline and it raises the pH, but you need the pH to stay below about 4.2. So if you use a blender, you can take a subsample of the kelp, about a pound or so of kelp, and then a pound of the liquid, stick it in a blender, and then immediately take the pH and get what the reading will become after it sits in the brine for a day or two. And from there, you can make adjustments and you can make your brine more acidic if it needs to be, or on your next batch, add slightly less acid. And then you just put everything into your totes or your barrels, which does require some thinking through how you move thousands of pounds of kelp effectively. But again, you're just weighing this, and we were using 1-to-1. And the key part of this is just making sure you're pushing out as much air as you can. And then from there, we've had the various kelp stored for a total of 12 months and still going, and we're still testing on that. And then the final part, just because our food safety officer would not be pleased with me if I didn't mention this, is we have every hope that we can use this and then have outlets as food grade, but you still have, and we still have, more additional work to do here, including a validation study where you actually challenge it with these microbes and carefully follow HACCP plans and make sure that the methods we're using match the challenge experiment, and then verification of each batch. So I just want to make sure people aren't being like, oh yeah, Atlantic Sea Farms says this is all safe, let's go and eat this. And even though we have, and we've tested this ourselves on every sensory component. So that's, yeah, my project in a nutshell, and happy to take questions, Q&A.
Thanks for sharing. How long does the validation take? Or I don't know what the back and forth on that is.
Yeah, so the validation is, I'm going to stop sharing my screen here. So the validation is done by a third party. We've used Cornell Food Labs in the past, and it's a couple-month process. And right now, I mean, it's a matter of, why can I not get this off? Sorry. There we go. Stop share. There we go. Yeah, you work out exactly how you're doing it, and then they replicate it at their facility in Cornell, or there are other companies that do this, and they inoculate the initial kelp and then follow your procedures and then monitor it at 1, 3, 6, 12 months and make sure that all of those microbial nasties that they've intentionally added to it uh, do not live and thrive or stay. And at the same time, they're looking at each component of your plan and looking for ways that it could be improved, or is, potential pathogens or biological, chemical concerns could come into it.
Okay. Do we have any other questions here from the chat?
Sue, what kind of a shredder were you using?
So we have our own shredder, which is a luxury I realize that most people don't have. And I couldn't tell you right now what the make and model of it is. But yeah, we're kind of spoiled here in that our shredder can do about 10,000 pounds an hour. And then we don't use a helical or screw. We actually just use a conveyor belt to move it. It's just a very simple it's got a rubberized conveyor that lifts it and fills in.
Thank you.
Great, thanks so much. Well, I think we'll move on to our last presentation of the day here. We have Maya with Float Camp, and she'll be presenting on her project of evaluating marketability and production protocols for kelp-based wine and spirits. And let me just ensure that she is able, let's see, can you unmute? 1 second here, Maya. Did that work?
Can you hear me now?
Yes.
I think so.
Pull up the slides here for you.
While she's pulling it up, I'll just get kind of started quickly on it. This project was to develop, let's see if it's also develop kelp-based wines and spirits. And so it started as a very simple fermentation process, and then worked with the winery consultants and distillery consultants to look at what would be the next best step for this. And the recommendation was to go to distillation, which is where Uncharted Distilleries here in Ketchikan got involved and started using the recipe, adjusting it to make it better for the distillery, and continue to create a kelp-based vodka, basically distilling kelp wine. Yeah, if you could, can't make these go, I don't think. Yeah, and so this all came about down in Texas. There's a lot of homemade wines, and there's a very, very good winemaker down there. And the general feeling is if it doesn't walk away from you, you can make it into wine, which honestly, from what I've seen, it's really true. Could I go through a couple of these? So that was just really small scale fermentation, trying it with everything from chili to mesquite to lemons to whatever. We keep going. If you might hit that again. Yeah, so it was just the recommendation to distill it. And then, yeah, because Marco says our seed grove was great about not looking at me like I had 5 heads and said, sure, you want to try? We've got some kelp for you. I'm going to keep going here. Now, they went ahead and took it down to the Alaska Symphony of Seafood and did very well down there. This whole fast vodka is being sold through Uncharted Distilleries, and they'll be selling it for this tourist season. Ketchikan, we get 1.5, 1.8 million cruise ship passengers annually. So this should sell well. They're putting it at a pretty high price point. I think it's going to be $60 a bottle this year. Cue the next one. Now, I had both dockside marketing studies, which are a little challenging with the cruise ship passengers, and also national marketing studies performed. Both the studies showed a really strong interest in the kelp. But what's important here is that what is important about it is uniqueness. Alaska, nobody cares really about it except for the tourists. The tourist market, they have got some preferences for their packaging to be lighter. National just wants glass. Everybody, national or the dockside passengers, all want to sample it just to know what it's like. The people who are willing to sample is huge. And so the marketing study showed that people who'd actually be interested in it is also quite large. And they're seeing it more as a premium product, which can be very, very beneficial for your sales. I think I might have one more past that.
I think this is it.
Oh, okay, perfect. Okay, so where is it going now? Uncharted is going ahead and continuing with it here in Ketchikan, and I'm talking with custom distillers down in Washington. My interest is more the national market, and we're working on readjusting the formulas so that the recipes will work better in very large facilities. Challenges that we're running into is, I'm wondering if through Southeast Conference or any of the organizations, if they have contracts to decrease the cost of shipping going down. And besides that, the only other issue we're running into is finding videos for the farms, Alaska, to be able to QR code back into these packages. Because I think it's really what it comes down to is people want something fairly natural. Sustainable is really only important to about 15% of the population that we're seeing. The rest just really don't care. But they do want uniqueness. That is extremely important. And I think that needs to be encouraged, and showing it through the videos, showing what Alaska looks like, what are people doing up here, because face it, there's not very many people down in the South who's ever even seen what a kelp farm looks like or what it's like out on a boat. And the scenery here is gorgeous. So that combination really helps with the uniqueness aspect of this. I guess that's most of it. Any questions?
Thanks, Maya. I enjoyed going through the research study yesterday after you sent it to me. It is interesting results, and I do like the idea of having a QR code link to videos of farms, and I'm sure there's a way that we could put that together.
It would be really nice just in general for Alaska, for the kelp industry, if you guys could make a map of all the different kelp farms where you could click on each one, a video would pop up of each farm, and maybe also some restaurants and bars with recipes and for drinks or for using the kelp to make miso soup, etc.
Yeah, that's a great idea. We have a question here. Maya, can you expand on your method, wine to distill steps?
Sure. It's very much like if you're making a fruit wine, very similar process. Simply substitute kelp for the fruit and just go ahead and use most of the standard recipes will work. You just have to watch your specific gravity because you are going to have to add sweeteners. The yeast that are available today that are approved for USDA use in foods, unfortunately, do not handle mannitose, which is what is in sugar kelp mainly. It's fructose, sucrose. So you do have to add in order to do the fermentation. Once you have that first fermentation, which takes about 7 to 10 days, you can now take that away from all product and that can be distilled. And then if you want to take it a step further, once you've made it into vodka, you can then take that vodka and put it through baskets through another distilling to create gins, or you can put it into charred barrels and create a now barrel-aged vodka, which is similar to how a whiskey is made. Does that answer the question?
Yeah, that's great.
Yes, thank you.
Yeah, the vodka was very successful at the AFDF Symphony of Seafood, and it is very tasty. All right. Well, if we have no further questions here, I'll just give it another few seconds if anyone has anything for Maya. I think we can go ahead and wrap up the meeting here a couple of minutes early. I just want to thank everyone for their participation both today and last Friday. It's really exciting for me, and I know for many others, to just see the results coming in and see all of the work that you have been doing over the past year or a year and a half. And thank you so much for taking the time. We hope to do a similar meetup for the next round of joint innovation projects, which will be more of an interim check-in to see progress, and that will probably be happening around June or so. So stay tuned for invites to that, and I will make sure to keep this first cohort in the loop on the scheduling for those as well, so we can all stay in touch. And again, we'll have these videos and clips posted up on the Alaska Mariculture Cluster website shortly. So just want to thank everyone and have a great rest of your day.
Thank you.